Okay, so today we're going to take the world of right triangle trigonometry, which we were living in on Friday, and we're going to expand that to doing some trigonometry on the coordinate plane. Okay? And we're just going to take a look at the first quadrant here to begin with. All right, and we're going to put a 45, 45, 90 triangle on the coordinate plane here. So this would be our x, our y. And so here's going to be our 45-degree angle. Okay, and we're going to make the hypotenuse of this triangle equal to 1. So if the hypotenuse of that triangle is equal to 1, what are the distances of the other two legs? Yeah. Go for it. Which simplifies to, what do we end up writing those fractions as? Yeah, square root 2 over 2. So, if this is a point on the coordinate plane, what are the coordinates of that point? So, everybody okay with that? Okay. And do you see how this is the same thing then as that? The coordinates of that point are simply the cosine of 45 and the sine of 45. Because take a look. This number right here, if the hypotenuse is a 1, how do you do a cosine? Adjacent over hypotenuse, right? This number over 1 is just this number, right? And the sine of 45 would be this number over 1, which is just this number, right? So do you see how these are the same thing then? So if I wanted to find the coordinates of this point, it's simply the cosine of the angle and the sine of the angle down there. Okay? I'm going to do this again, and we're going to put a 30, 60, 90 on here. Okay? And see if we can come up with the coordinates for that one. Okay, so for this one, this would be the 60. This would be the 30. And again, we're going to make the hypotenuse 1. This would be our x and our y. So, the short leg of this triangle, if the hypotenuse is 1, should be what? Yeah, 1/2. And the long leg of this thing, then, somebody other than Josh, should be what? You're close. Square root 3 over, not 1, but 2. Okay, so, coordinates of this point up here then, x, y, should be 1/2 square root 3 over 2, which is the same as doing what? Cosine 60, sine of 60. Right? Again, the adjacent over the hypotenuse, the opposite over the hypotenuse. Okay, so that's doing that for a 60-degree angle. Okay, one last time. We're going to put another 30, 60, 90 on this thing, but I'm going to put the 30-degree angle at the origin this time. So 30 degrees is here, 60 degrees is up here. We're going to keep that hypotenuse a 1. So now the other two legs should just swap, right? Along the x-axis, it should be square root 3 over 2. And the height of that triangle is the 1/2. So the coordinates of that point, what's going to happen then? They're just switched, right? The x and the y are switched. So square root 3 over 2 and 1/2, like that. Which is the cosine of 30 first and the sine of 30 second. Okay? Do you notice that all of these triangles have a hypotenuse that is 1, right? So if I put all of these triangles together on 1, I would have a bunch of points, these 3 points that we looked at, 3 points that would all sit on the same circle, right? It would be a circle of radius 1, right? Starting in the center would be at the origin, and this thing would just be sweeping like that, and each one of those points would be on the edge of that circle. Okay? This is the beginning of the unit circle. This is where it comes from. A unit circle is called a unit circle because it is a circle that has a radius of 1 unit. Okay? So I'm going to quickly draw a little portion of the unit circle with all 3 of these kind of condensed down into that one quadrant. Okay? So we have everything going on all in the same place. Let's see. This look right. Something kind of like that. Okay, so here's our first quadrant, and this is going to be the x-axis coming out here, and I kind of ran out of room over here. Sorry, I'm getting in the way of my other triangle there a little bit. So on that circle, we said if we went at a 45-degree angle, so kind of like this, we would hit a point, and the coordinates of that point would be square root 2 over 2, square root 2 over 2. That's the 45. If we had one that was only going 30 degrees, like out there somewhere, okay, so that angle at 30, we'd have a point on there. And that would be square root 3 over 2, 1/2. And then if we let it go all the way up to 60 degrees, well, that's not good. Let's make it actually look right here. Alright, so we had one going up here. If that was a 60-degree rotation, then up there we'd have an ordered pair that was 1/2 square root 3 over 2. And like we talked about with all of those triangles, the first number of each of these ordered pairs that we came up with is the what of the angle? Cosine. And the second number is always the sine, because those how those triangles all fit in there. Okay? So if I have these kind of on a little circle like this, it's a real quick way for me to visually see the cosine and the sine. Okay? So just looking at this, what's the cosine of 45 degrees? Square root 2 over 2. What's the sine of 60 degrees? Square root 3 over 2. What's the cosine of 30? Square root 3 over 2. Okay? And then I could also swap them into radians. Okay? And maybe off to the side here just as a reminder. 60 degrees is the same thing as pi over 3. 45 degrees is the same thing as pi over 4. And 30 degrees is the same thing as pi over 6. Okay, so what is the cosine of pi over 6? Square root 3 over 2. What is the sine of pi over 4? Square root 2 over 2. And what is the cosine of pi over 3? 1/2. Take a look at that one. Cosine of pi over 3. 60 degrees, right? So that would be 1/2. Okay. Now, what this allows us to do, because of these patterns that are happening in here, where all these points along this unit circle are simply the cosine and the sine of some different angles. And remember, this is a circle with a radius of what? 1, right? Each of these is 1 unit. So keep that in mind. Let's see if you can do this for me then. So this is 1, this is 1, this is 1, this is 1, this is 1. What's the cosine of 0? 1. Because if I put an ordered pair over here, and this is 1 unit, what are the coordinates of that point? 1, 0. So what's the cosine of 0? 1, right? This is 0 degrees, right? I haven't rotated yet. Cosine is 1. What's the sine of 0? 0, right? Cosine, sine. Okay. What's the cosine of 90 degrees? 0. I'm up here now, right? What's the sine of 90 degrees? 1. Excuse me. Just making my point, and then I got embarrassed. Because that's 0, 1, right? Okay, so cosine, sine again, right? Cosine of 90 is 0. Sine of 90 is 1. So we can do that too. And in fact, what this allows us to do is, not only in the first quadrant, but all the way around in a full circle, hence the unit circle, I can get sines and cosines of whatever I want. Okay? So what we're going to do is we're going to start to kind of piece together what this unit circle should look like as we go all the way around. Okay? And then what that's going to allow us to do, like I said, is to find cosine and sine of all of these angles. And we can make them positive angles. Again, think about rotations. I can make positive angles by rotating counterclockwise. I can do negative rotations by going clockwise. And I can do sines, cosines, and even tangents, secants, cosecants, cotangents, all that business everywhere else on that unit circle. Okay? How do you get the tangents?
Is it like cosine over cosine?
Yeah, tangent, and we'll talk a little bit more specifically about this later, but since you brought it up, a tangent is also defined as sine over cosine. Okay? Because sine, think about on a right triangle. If you do a sine, you're doing the opposite over hypotenuse, right? And when you're doing a cosine, it's the adjacent over hypotenuse. Do you see how the hypotenuse and the hypotenuse will technically cancel each other out? And what are you left with? Opposite over adjacent, which is the way we find a what? Tangent. So it's an okay way to find a tangent, to take the sine and divide it by the cosine. So, unit circle time, if you wanted to find, let's say, the tangent of 45 degrees, come up to here, here's the sine, here's the cosine, this divided by that, 1. Tangent of 45 is 1. If I wanted to do the tangent of 60, square root 3 over 2 divided by 1/2, square root of 3. The 2's cancel. If I wanted to find the tangent of 30, it'd be 1/2 divided by square root 3 over 2. Should be what? 1 over root 3. 2's cancel again. Okay, since we're doing it, tangent of 0? 0. 0 divided by 1. Tangent of 90? Undefined. We'll talk more about that later. But yeah, because it would be 1 divided by 0, you can't do that. So yeah, there is no tangent up there. Okay. So what we're going to do is we're going to construct unit circles. And I've got some paper from my printer that I will allow you guys to do this with. In fact, I'm going to stop recording because we don't need to record this. But, okay. So wanted to talk a little bit about what we have right here as far as how you can use this to help you remember what's what. For me, I can do all of these in my head because I know one fact. The square root of 3 over 2 is greater than 1/2. And then I just look in my head at where the angle is and think about, is the cosine bigger there or is the sine bigger there? Okay? And that helps me to decide which one of those two it should be. Okay? Some of you guys have probably already started to notice cosine and sine. If it's anything pi over 4, square root 2 over 2 every time, right? And those are going to become the easy ones. Then it's a matter of, okay, I've got pi over 3 or pi over 6. So is my answer square root 3 over 2 or is my answer 1/2? And then for some of you, I think it's just a guessing game still. I'm going to go with 1/2. Hope I'm right. I'm going to go with square root 3 over 2. Hope I'm right. Well, if you use the fact that the root 3 over 2 is larger than 1/2, then you can kind of do it in your head. So think, all right, so when I'm at pi over 6, which is this 30 degrees, which is larger, the cosine or the sine? The cosine. And you can see that geometrically, right? On the graph, if I'm only up pi over 6, do you see how I have to go further in the x direction than I do in the y? The x is bigger. The cosine is bigger. So what is the cosine of pi over 6? Square root 3 over 2. It's the bigger of the two numbers. Okay? Now, when I'm up at pi over 3, 60 degrees, up here, okay, I have to go further in the y than I do in the x, right? So what's bigger, sine or cosine there? The sine would be bigger there, right? So then the sine of pi over 3 is what? Square root 3 over 2. The bigger one, right? So see if you can start doing that, okay? The more you look at your unit circle and kind of see those patterns, you can think about that. So if I give you a flashcard like, you know, sine of pi over 3, okay, so pi over 3, that's going to be this way. So the y is the larger. I want the sine of pi over 3, so that should be square root 3 over 2 because that's the longer one. Okay? Or if I was going to do, what's another one? Sine of pi over 6. Okay, pi over 6, that's not a lot of a rotation. I have to go further in the x than the y. The y is the smaller of the two because I want the sine, so that's only 1/2. The answer, that's 1/2. Yeah?
You know everyone on the unit circle?
Mm-hmm.
Really?
Yeah.
Can I test you?
You can test me.
What's tangent of 4 pi over 3?
Tangent of 4 pi over 3. So 1, 2, 3. So 4 pi over 3 is down there. So the tangent is the y over the x. The y is larger than the x. So it's square root 3 over 2 divided by 1/2. It's square root 3. You can do it too. Just take some time. Anyway, so now, right now you guys are at a point where if you look at the unit circle, you could tell me the sine, cosine, or tangent of any angle that's on here, right? I think we're all capable of that, just finding where we need to go and getting it. Well, we can expand that a little bit by using what are called coterminal angles. Okay, so let's chat a little bit about that. So, if I want to rotate more than 360 degrees or more than 2 pi, I can still get sine, cosine, and tangent for those angles because those angles end up ending in the same place as other ones that are on your unit circle. Okay, so coterminal The prefix co means together, and terminal means end. So coterminal angles, they end in the same place. Okay, so for example, let's say I've got the angle pi over 4. Okay. So a rotation that'll put me in the same place as pi over 4 would be one that goes all the way around and then to here. Okay. So how many radians is that to make one complete circle and then a little further? Yeah. 9 pi over 4. And you can count it out here too. All right. So 1 pi over 4, 2, 3, 4, 5, 6, 7, 8, 9 pi over 4. So 9 pi over 4 and pi over 4 are coterminal angles. Okay, can somebody give me another angle that is coterminal with pi over 4? 17 pi over 4. Okay. So it'd be another 8 pi over 4 added to that. So 17 pi over 4 also works. Then 25 pi over 4. So all these are just adding additional rotations onto it. Now, there are other ways that we can do it, and I think some of you guys maybe know this. Yep.
Negative 7 pi over 4.
Yes. What's a negative angle? You just rotate the other way, right? Okay, so if I want to go negative 7 pi over 4, let's verify that real quick, that ends up in the same place. So negative pi over 4 is right here. Negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4. Works. Okay? And then any other, additional rotation that you want to do would put you there. So negative 15 pi over 4 would also work. And you can do this till you're blue in the face. There's infinite numbers of them that will work. Okay? It's just you keep putting on additional rotations, whether you're rotating clockwise or counterclockwise, you're going to end up in the same place. So what I'm going to do is I'm going to give you an angle, and I want you to give me 2 other angles that are coterminal with it, one positive, one negative, and just see if we can do that for a few. And once we're good there, then we'll start applying the trig to it as well. Okay? So, and we'll do some degrees and we'll do some radians here. So if I give you an angle in degrees, give me the other 2 in degrees. If I give it to you in radians, give me the other 2 in radians then, okay? So let's try 120 degrees and 3 pi over 2. So can you get me a couple of coterminal angles with those 2? One positive, one negative. So if you need to look at your unit circle to help you with that, that's fine. You can do that. I'll give you a couple minutes to do that. Okay, anybody got some? Okay, yep. 480? Sounds good to me. So we just add 360 onto that, right? One more full rotation, we get to 480. Okay, good. Anybody got the negative one to go with that? Yeah? Negative 240 degrees would work. Okay. How'd you get the negative 240? One person tell me. You answered it, so go for it. How'd you get 120 minus 360. Okay, yeah, good. 3 pi over 2. Somebody got one of those for us? Yep, Mr. Wheeler. 7 pi over 2. Okay. So if we... Well, you tell me. How'd you get that?
You add 4 pi over 2.
Good. Right. And the reason you did 4 pi over 2 is because that's equivalent to 2 pi, right? That's a full rotation. Good. So add 4 pi over 2. We're at 7 pi over 2. The negative one for that one, anybody? Yep.
Negative pi over 2.
Good. Negative pi over 2. Awesome. So if I ask you for, let's say, like the cosine of negative pi over 2 or the sine of 480 degrees or whatever, we can do that too then. We just got to figure out where's the coterminal angle that is on your unit circle that will tell us the answer. Okay? So let's see if we can do some of those. Okay? I'm going to give you some angles that are not on your unit circle, but if you figure out the coterminal one that is, then you can just look and do it just like we've been doing. So let's do the cosine of 540 degrees. Do the sine of 17 pi over 6. And the tangent of negative 2 pi over 3. All right, so take a minute. Go ahead and use your unit circle. That's totally fine. See if you can match them up and then evaluate the cosine, sine, and tangent for those three. I'll do one more here too, just for fun. Yeah. Try that one too. You got the other three done. That's cosine. I think I think it's a billion? Yeah. Cosine of a billion pi. Let's do that. Cosine of a billion pi. Don't use your calculator. Find the coterminal angle on your unit circle. You have to think about it a little bit differently, but when it clicks in, it's like, oh. It's not as bad as you might think. Cosine. All right. Do you guys need more time with this? And again, we should be doing these without a calculator, correct? Because that's kind of cheating at this point. Okay, so cosine of 540. What is the coterminal angle for 540 that's going to help us do this one? 180. Okay, so this is the same thing as doing cosine of 180 degrees. Okay, so what is the cosine of 180 degrees? -1. So that should be -1. Yep. All right, what is the coterminal angle for the 17 pi over 6? Yes, sir. 5 pi over 6. Good. So this would be the same thing as doing the sine of 5 pi over 6. Okay, so find 5 pi over 6 on your unit circle. What's the sine? 1/2. Yeah. Good. Okay, tangent of -2 pi over 3. So what is the coterminal angle for -2 pi over 3? Yes, sir.
4 pi over 3.
4 pi over 3. This is the one I got challenged on earlier. So what is the sine, or the tangent rather, of 4 pi over 3? Square root of 3. You do the square root of 3 over 2, or I guess negative square root of 3 over 2 divided by -1/2. It's square root of 3. Yep. And then my cosine of 1,000,000,000 pi. What's the coterminal angle with 1,000,000,000 pi? Yeah. 2 pi. Or 0, depending on how you want to look at it. How did you know that? Did you sit there and like count that all the way up? And wow, really? Amazing. Okay, so the good. I'll look for that later. The important thing is to recognize that 1,000,000,000 pi is a multiple of 2 pi, right? So anytime you are a multiple of like that, then you know it's going to be in the same place. So this is the same as cosine of just 0 or 2 pi, depending on how you want to look at it. And the cosine of 0 is what? 1. So the cosine of 1,000,000,000 pi is 1. Okay. All right. So I'm thinking you guys are getting pretty decent at these, so I'm not going to belabor that. But there's one other type of problem that I want to work on with you guys, and then I think we're good. And this is going to do a little bit of right triangle trigonometry. Okay, so something like, actually, you know what? I'm going to change this. We'll make this negative. Okay, so this is a little different. Find the sine of theta and the tangent of theta if the cosine is 3/4 and the cotangent is less than 0. Now, if this was just strictly, you knew it was a right triangle that you were working in, you guys could probably do this without too much trouble. You draw the right triangle, you get the other measurements, and there you go. But this kind of screws the deal a little bit, this cotangent less than 0. In a right triangle, are any of those ratios ever negative? If you're just working in a right triangle, everything's always positive, right? Okay. So we need to think about unit circle rather than a right triangle here, really, when it comes to what's positive and what's negative. So on the unit circle, cosine and sine are positive and negative in some different places. So just on the board here next to here, I'm going to just remind you what's happening with cosine and sine in these different quadrants. So first quadrant, positive or negative Cosine and sine. Both positive, right? In the second quadrant, what changes to negative suddenly? The cosine. And then in the third quadrant, what's happening? Both negative, and then in the fourth quadrant. Okay. So if I know the cotangent, in the problem it says the cotangent has to be less than 0. So what quadrant or quadrants is the cotangent less than 0? Yeah.
2 and 4.
2 and 4. Does that make sense? Has to be one of those two quadrants. Because a cotangent is, well, let's chat about that a little bit too. A tangent, we talked about before, you do by doing sine over cosine. No, the cotangent needs to end up being negative. That means the cosine and the sine have to have opposite signs, right? One has to be positive, one has to be negative. I don't know which one, but I know it has to come out that way. So then the question becomes now, okay, of these two quadrants, is there something else in here that would tell me, is it the second quadrant for sure, or is it the fourth quadrant for sure? Yeah. Good. I said the cosine was 3/4, not negative 3/4, positive 3/4. So I need the one of those two that has the cosine coming out positive. Which would be the, okay? So, for this problem, I know I'm working in the fourth, okay? And we can approach this still doing that kind of right triangle type stuff, but just make sure that the things that are positive, and the things that need to be negative are negative when you do that, okay? So, simply for calculation's sake, I'm going to draw a right triangle, but things are going to start switching negative because we're in that fourth quadrant. So let's say theta is down here. Cosine, adjacent over hypotenuse. So we're going 3 and 4. And then I need this other one as well, right? So if I do a little Pythagorean theorem work here, 3 squared plus b squared equals 4 squared. So 9 plus b squared equals 16. So b squared, 16 minus 9 is 7. So this is the square root of 7. All right, so I know I've got square root of 7 over here. Okay, so if I was just using the right triangle, what's the sine of theta and what's the tangent of theta? So somebody give me the sine. Square root 7 over 4. And the tangent? Yeah, root 7 over 3. Okay. But I know I'm in the fourth quadrant. Okay? So, in the fourth quadrant, is the sine positive or negative? It's negative. Okay? So I got negative. And in the fourth quadrant, is the tangent positive or negative? Negative, again, because the sine and the cosine have opposite signs there. So I got to change that to negative as well. Okay, so technically, to fit this description, the sine of theta would have to be negative root 7 over 4, and the tangent would have to be negative root 7 over 3. Okay, so your first goal is to figure out what quadrant you're sitting in. Then you can do all your right triangle stuff like you normally did, but then at the end, just double check the signs. Are these supposed to be positive, or are they supposed to be negative? And each one you got to check. Does that make sense, how to do that? Silence is a yes? Okay, good. All right, that's all I got then. So rest of the time, I'll let you guys work on your homework here then.